Alright, hello mathematicians. Today's video is about probability. Now before we start this video, it's really important that you are not just taking notes while we watch this video. There's going to be a lot of different vocabulary, a lot of different definitions, a lot of explaining of the kind of background knowledge and the basics of probability. And because of that, it's really important that you are actively listening as you watch this video. So our objective for today is students will be able to compute probabilities of simple and compound events. So students will be able to compute probabilities of simple and compound events. What we're looking to do here is we're going to look at a bunch of different ways probability can kind of manifest itself and how we can illustrate probability and talk about events that are simple and events that are compound, which is something that we'll get into a little bit later in this objective. Okay, so the first thing I want to do is let's just define what probability is. So probability is the chance or likelihood of an event happening. The chance or likelihood of an event happening. If you need to, take a minute, pause your video, you can copy this down and then resume the video so you can hear the explanation. So when we talk about probability, we're going to use this line right here to kind of illustrate what's happening. We need to think of probability on a scale of 0 to 1. 0 meaning it's not happening, guaranteed, not happening. Guaranteed, not going to happen. So, for example, if I asked you, what's the probability that a dog could talk? Well, that's not going to happen, right? Dogs don't talk. Dogs can't talk to you. They can bark, but they can't talk to you. So that's guaranteed. The probability of that is 0%. Guaranteed not to happen. Okay? We can think of that as the chance of that happening as a 0, or we could also think of it as a 0%. On the other end of the spectrum is this will happen. Will happen. Guaranteed to happen. Right? So for example, I might say, what is the probability that you will take the end of year Explore? That will happen. We will take an end of year Explore. That is guaranteed to happen. So the chances of that happening are 1, or it will happen. We could also think of that as 100%. Now in the middle here is all the other stuff that could happen or it could not happen. There could be a chance. So we can think of the middle part right here as a 0.5 or a 1/2. We also could think of it as 50%. Right? So for example, I might ask you, I go outside in the morning and I look outside and it's a little bit cloudy, and I could say, what do you think is the probability that it's going to rain today? Or what's the likelihood of it raining? Well, that likelihood might be about 50%. There's probably maybe a 50% chance that it's going to rain because I look up and it is sunny out. Now, I'm sorry, it's rainy out, not sunny. So that's about 50%, right? And people use probability all the time. When you listen to the weatherman in the morning and he talks about the probability or the likelihood it's going to be a certain weather, he's dealing with probabilities. It could happen, it could not happen, but it's probably somewhere in between. So let's kind of talk about a couple different probabilities. In general, when we write out probabilities, they're written like this. P, and then we have a parenthesis, and then inside we have some sort of event. And what that's saying is, what's the probability of this event that I've put inside here happening? happening. And we'll have some sort of fraction or a percent. So here's just a couple of examples. What's the probability it will be cloudy out? So how I would write this is P, our probability of it being cloudy. Well, I'm looking outside today, and it's pretty gray, and it's pretty cloudy out. It looks like it's going to rain, I think, on my way to work this morning, and even a few drops to fall. So I might say, oh, the probability will be cloudy will probably be maybe about 75%, okay? There's a let's say 75% or 3/4 chance. So I might put that right here, okay? A 3/4 or a 75% that it's going to be cloudy. Okay. What's the probability I will wear a black shirt? Right? Now, that could be all sorts of probabilities, right? Because maybe you only have a black and a white shirt. You only have 2 shirts to pick from. If you pick a black shirt, you have a 50% chance of picking it. If you pick a white shirt, that's a 50% chance of picking it. If I will flip tails on a quarter, so what's the probability of flipping tails? Now, when we talk about something like a quarter flip, right? Think about a quarter. You have 2 sides to a quarter. You have heads and you have tails. When I flip a quarter, one of 2 things are going to happen. I'm either going to get heads or I'm going to get tails. So we might say, well, tails is 1 out of 2 different options, so I might say the probability of that is a half, or 50%. What's the probability that pigs will fly? So I could put probability pigs fly. Now, I think the probability of pigs flying is pretty low, really close to 0%, but then some people say, well, what if a pig was flown through the air? Technically, could that be flying? I don't think so, but I'm saying that pigs flying is probably like a 0% because pigs don't fly. And then lastly, I will blink within the next minute. So the probability of blinking. Okay, your eyes need to blink in order to stay moist so they don't dry out. So I think the probability of me blinking in the next minute is probably 100% because my eyes are going to blink. So right here, this is the basics of probability that we need to think about. We need to think of it on a scale from 0 to 1 or 0 to 100%. Remember, when we write out our probability, we're going to write P, and then inside our parentheses, we're going to write an event like cloudy or shirt or tails. So let's keep going, and let's kind of investigate all the different kinds of probability that we can see. All right, next we're going to talk about the 2 different kinds of probability that you can have. One is called theoretical probability, and the other is called experimental probability. So if you kind of just think about these words and what they mean, we can kind of figure out what the definitions might be. So experimental probability is going to be an event or an action is taken Okay. We're actually doing an event or an action. So for example, I might ask you, what is the experimental probability of tossing a coin? To find the experimental probability, we'd actually do an experiment. We would flip a coin, or we'd actually do the event or action. Once we've done that, or as we do that, as trials happen, as we actually flip our coin, outcomes are reduced. And I'll explain what that means in a second. We would write our experimental probability as the number of times an event actually occurs over the number of trials. So I'm going to give you an example. Let's say that I want to flip a coin 5 times. So I have, here's my first flip, here's flip number 2, here's flip number 3, Here's flip number 4, and here's flip number 5. If you need to, pause the video for a second and write everything down so that you can make sure you are actively listening to this explanation. So I'm going to flip my coin. Now I know when I flip a coin, I can have two things happen. I could get heads or I could get tails. And let's say on my first flip, I get heads. My second flip, I get heads again. My third flip, I get heads. My fourth flip, I get heads. And my fifth flip, I get tails. So how would I write my experimental probability? Well, I'd say, okay, the number of times an event actually occurred. If I was looking for the probability of heads, I would say, all right, well, how many times did I get heads? The number of times the event actually occurred, 1, 2, 3, 4. Over the number of trials. How many flips did I have? 1, 2, 3, 4, 5. So the experimental probability of getting heads was 4 out of 5. Because experimentally, when I actually did it, I got 4 out of 5 heads. And that's what it means by trials happen, outcomes are reduced. Experimentally, my probability of getting tails is really low. The outcome for that is low. But experimentally, my probability for heads is really high, because in this experiment, I happen to get heads 4 times out of 5. Now let's look at theoretical probability. Theoretical probability is what should happen. Okay, and that's the easiest way of thinking about it. It's what should happen. We write that as the number of ways an event can occur over the total number of equally likely, likely outcomes. The number of ways an event can occur over the total number of equally likely outcomes. Take a minute and pause the video if you need to so you can make sure you have all this down before we keep going. So if we did the same thing and I asked you, what's the theoretical probability of getting heads? The theoretical probability of heads. Well, theoretically, when I flip a coin, it means what should happen. Well, when I flip a coin, I can either get heads or I can get tails. There are two total number of equally likely outcomes. And how many ways within that can I get heads? Just 1. So 1/2 would be our probability of getting heads. You'll notice that these two are different. Okay? Theoretically, what should happen is about half the time you should get heads. But experimentally, in this experiment we did, that didn't happen. And that's okay. Most of the time we use theoretical probability. All right, let's talk about a couple more vocabulary words. We're going to talk now basically about how do you compute probability. We compute probability very similar to how we compute theoretical probability. We're thinking about what should happen based on what's there. So to compute probability, we're going to do this. We're going to have the number of desired, or think about it as what we want, outcomes, over the number of possible outcomes. Over the number of possible outcomes. So I want to give you an example of how this kind of works out. Let's say, and write this example down, that we have a spinner. And on this spinner, we have all this spinner, we have 5 sections. So 1, 2, 3, 4, and 5. They're labeled 1 through 5. Let's say that I asked you, what is the probability of getting a 5? What's the probability of spinning a 5? Well, first I want to look, okay, what's the desired, number of desired, or what we want outcomes? How many ways in this spinner can I get a 5? If I spun the spinner, how many ways could I get 5? Only one. There's only one section that's 5. So my desired number of outcomes is 1. How many things could happen? What are the total possible outcomes? Well, I could spin a 1, a 2, a 3, a 4, or a 5. So there is 1, 2, 3, 4, 5 things that could happen. So my probability of spinning a 5 is 1/5. Okay. We might think of another example could be, what's the probability of getting a 1 or a 3? Okay, so think about, what is my desired number of outcomes? How many ways can I get a 1 or a 3? Well, there's one way I can get a 3. There's one way I can get a 1. So together there are 2 ways I could spin, because I could either get a 1 or a 3. And then how many total outcomes could happen? 1, 2, 3, 4, 5. Now, what if I asked you maybe, what is the probability of not getting something? Okay, when it says a not probability, we're going to think of that as the probability an event will not occur. The probability that an event will not occur. So think about it in terms of our scale from before. We went from 0% to 100%. If something will not occur, we need to be over here, guaranteed not to occur. That's that 0% mark. So let's use this same spinner from above, and let's think of this example. Okay, what if I asked you, what is the probability of not spinning a 1? So I might write that as the probability of not a 1. When we do this, we're going to say, okay, the desired number of outcomes. We do not want a 1. That means that we could spin anything else but a 1. So how many numbers do we have that are not 1? 1, 2, 3, 4. Okay. How many total possible outcomes were there? Well, still 5. So the probability of not a 1 or not spinning a 1 would be 4/5. Another way of doing that is to think of it in terms of a whole number. If we know that the probability of spinning a number is 1, okay, we're going to spin something. What's the probability of spinning a 1? Well, a probability of spinning a 1 would be 1/5. There's one way to get a 1. And if I subtract 1 minus 1/5, I get the probability of not spinning a 1. So also, if you take the probability of spinning something away from 1, you can get what it is to not spin that. Okay, we had a few more vocabulary words. Big vocabulary words that kind of relate to this is a complement, okay, and a complement event. And let's add the word event at the end of this. A complement event. So the complement of event A is all possible outcomes, but not including A. Okay, take a minute and write this down, but pause the video if you need to make sure that you can listen to the example that I'm going to give. So let's do an example. Let's say that we have a spinner, okay? And on this spinner, we have red, we have blue, and we have yellow. And I asked you, what is the complement of blue? What's the complement of blue? What that means is, what are the other outcomes that you can get if besides blue? So look at the spinner. The complement of blue what are all of the events besides blue that can happen? Well, besides blue, the complement of blue, what else could happen besides blue would be red and yellow. You could also spin a red and a yellow. You also could think of it in terms of probability. Now, when I ask you the complement, that's just not the probability of it happening. That's just asking what are the other things that could happen. If I asked, what is the probability of the complement of blue, then we would say, okay, I know the complement of blue is red and yellow, but what's the probability that will occur? Well, red and yellow, those are two different things out of 1, 2, 3 options. So the probability of the complement of blue would be 2/3, but the complement is just red and yellow. When you think about complement, when we add the complement plus whatever the original was, we should get back to 1 or 100%. So if you think of it as the complement event, the probability of an event plus the probability of its complement should equal 1, or if you want to think of it in percentages, 100%. So if we think of this example, what was our event? What is the probability of our blue happening? The probability of blue happening plus the probability of its complement, and our complement to blue would be red or yellow. And does that equal 1? Well, the probability of blue would be 1 out of 3. The probability of red or yellow would be 2 out of 3. 1/3 plus 2/3 equals 1. So that works out. We did our complement correctly. All right, last thing I want to talk about is independent probability. Remember, you really need to be actively listening to the video so we can make sure that you understand what's happening and not just copying down the notes. So let's just define independent probability first. Independent probability is where one event does not affect the probability of another event. One event does not affect the probability of another event. So let's take our spinner again. We have a red, we have blue, and we have yellow. What this basically means is that when you deal with probability, everything is independent. If you spin a red the first time, it does not mean that you are more likely to spin a red the second time. The chances are just as equally likely. So an example we might give is if I get blue on the first spin, the probability of blue on the second spin is still 1/3. It does not change. Just because I spun it the last time. And it's really important to remember that probability is all independent. Okay, if you are spinning this spinner and you spin blue, the second time you spin, it doesn't mean that you're more likely to get blue the next time. You're still just as equally likely to get any of these colors. If you think about it in terms of somebody playing, flipping a coin, if they flip a coin the first time and they get heads, it doesn't mean that the next time they're more likely to get heads. They could still get tails. It's still a 50-50 chance. Because every time you do a trial or you do a spin or you flip something, the probability is equally as likely. The probability does not change after each time because they are independent events. Each spin or each flip is an independent event. Alright, that is the end of our video. Make sure that you write down any questions that you might have. If you are still a little bit unsure, I suggest you go back and watch the video again because there was a lot of vocab and a lot of talking, and come to class prepared to continue our lesson on probability.